All right, so good afternoon once again to everyone. Now, you guys should know that I gave you um, your coursework, and I think it's either the end of today or the end of tomorrow. I gave you guys to complete that. Two persons, two groups have already completed that coursework, so it's just for them to submit now and get their grades. So that coursework, I'm just looking for your problem statement and your IPO chart. You can start the pseudocode if you want, that's up to you. But this is mainly what I'm looking for: your problem statement and your IPO chart. Um, so when you guys are finished with that, basically, as we are learning, your IPO chart is going to be created first. So that's why I gave you the IPO chart as your first coursework. So as you complete that, you can go ahead and start your pseudocode. So that's what we're going to continue to learn about: how to create your pseudocode, so that using your IPO chart, as we've been learning, using that IPO chart, you guys can go ahead and create your pseudocode. So, but you should be able by now to create a basic pseudocode. A group has already created the complete pseudocode, so well done to them. So as I told you guys already, the textbook has examples of basically everything that you need. So it's just understanding the structure of your pseudocode and using the textbook as a guide, and you can create your pseudocode for your SPA. So are you guys clear on all that?
Yes.
Yes, yes.
Yes, sir.
Great. So this week is the deadline basically for your problem statement and IPO chart. So next week, I'm going to put as a deadline for your pseudocode. So by next week, we should be wrapping up learning how to develop pseudocode. So we're going to try to finish off that part of the SBA, so that sometime the starting of February, we start creating our program. We convert that pseudocode into our program and wrap up our programming SBA and complete our entire IT SBA. So soon we should be finishing with our IT SBA. If you guys work hard, work fast, work efficient, we'll be completing it soon. So let me pull up the whiteboard. And we'll type the link. Great. So as I told you guys already, let me just share this here and we'll go to the link so you guys can have access to that if you ever want to look at it. Oh, it's already in the chat. So as I indicated to you guys already, so you first create your IPO chart. So number one, you have your IPO chart. That's what you're going to create. Then number two, you're going to create your pseudocode. Now, what are the parts of the pseudocode? What is the first part of the pseudocode? Anyone?
Start.
Start.
Name.
What do you mean by
Sir, the title.
the title?
Yeah, the
Yeah.
title.
Very good. The title. So, I was actually reading through back the notes. The title indicates the start. So that's why you don't need to put the word start. It mentions it somewhere that adding the title is indicating the start of your pseudocode. Not sure if it's that one. I think it's this one here. right here, it mentions that the algorithm should start with a title. And notice it says ends with the keyword end. So that title is what indicates where it is basically starting from. And from that now, you are going to have your input, your processing, and your output inside of your pseudocode. So basically, the same input, processing, and output that you have in your IPO chart, you put in your input, you put in your processing. So that's why it's important to have that IPO chart. So when you reach this part of your pseudocode, you can easily put in these parts here. You know what you have to input, you know what you have to calculate. So when we say processing, we also mean calculate. So you know what you have to calculate. And from that calculation now, you know what you're gonna output. And then you basically end your algorithm. Where's your 2D? So that's a basic layout so far. So far we looked at how to create a basic pseudocode, how to indicate what is your input. So these are examples of indicating your input. This is an example here of processing. Let me put that in a different color. This here is an example of processing. And the very last one is an example of okay. So, quick question. What is the term that represents these words here? Input, add, output. What is the word representing them? What are they called?
Keywords.
Keywords. Very good. They're called keywords. And these keywords indicate what is happening. So the keyword input is indicating that something is being put into the program, something is being put into the computer. Output, the opposite. Add, that's indicating something is being added there. So I mentioned already that you can use the left arrow to indicate what is being calculated on the right hand is going to be stored on the left hand side. Now, what I did not mention, or what the notes did not mention, so if you notice here, you can also use equal sign, and that might be more understandable to you, to use that equal sign. So this here is an example of processing. This one is input, this one is processing, and this one is output, IPO. So notice that same IPO chart, it has that breakdown there. Now, what these pseudocodes do not mention is that you need to do something called declaring your variables. Does anyone have an idea what is meant by declaring variables? This has to do with creating your pseudocode. That one? Well, what does the word declare mean? Someone that has a dictionary, open Google. What does the word declare mean?
To make a decision.
To make something.
The last part, Alia, to make something.
Like to give it the power that what you say it is, that what it is.
Anyone else has a clear definition to declare something?
So in other words, it can mean like to present something or make it known.
Exactly, exactly. The exact definition I want. To make something clear or to make something known. That is declaring. So when you say you're declaring your variable, you are making known your variable. You are telling the program that, look, this is my variable. So we already learned what is a variable. A variable is basically something that stores a value. For example, we have this calculation of number 1 plus number 2 plus number 3. And where are you going to store that calculation? You're going to store it in a variable called result. But in the first place, number 1, 2, and 3 were already variables. These 3 were already variables because you can't add letters in the first place. So how are they calculating? They're actually variables that hold a value inside of them. So before you can use a variable, you're supposed to declare your variable. Now, how do we declare our variable? Does this have anywhere to type? Sticky notes. Okay, we can work with that. So how do you declare your variable? So obviously we need a title. So pseudocode pseudocode 1 or pseudocode underscore test as our title there. So we're going to use the same example that you see here. Read the 3 numbers, process the 3 numbers, and then output that result. So before all of that, you could put a section with a title called variables. That makes it more clear that underneath this heading here, we have our variables. So number 1 is our variable, number 2 is our second variable, and number 3 is our third variable. So we can list the variable. Now, in addition with listing the variable, you also have to see what is the data type of that variable. That's how you declare your variable, by mentioning what is the data type. So we already know that we're using numbers. So we have to choose either between integer data type or a real data type. So which would you guys use? Integer or real? You're inputting numbers to add. Would you choose integer or real? No one's gonna try?
Sir, real? Does he have a higher variety?
Okay. So it's gonna depend upon preference. Any data that you're gonna use, any data type that you're gonna use, it depends upon preference. So you have to ask yourself, basically, what do I want to calculate in the first place? Do I want numbers with decimal places, or do I just want whole numbers? So if you just want whole numbers, you don't want to deal with any decimal place numbers, you could use integer data type. So at the very end of the variable, you type in what is the data type. So in this case, I'm setting the variables to an integer data type. Likewise, you can also do real, whichever one is your preference. Now, You could also put them in the same line if it is the so you can do that, or you can put them in the same line. You can do number 1 comma number 2 comma number 3 comma, and you mention what is the data type at the end. So I'm going to put some semicolons at the end. In programming, you put a semicolon to basically indicate the end of a step or the end of a line of code. So we're going to practice doing that. At the end, we're going to use a semicolon to indicate that's the end of that line of code. So this here, we have two examples of how we can declare our variable here. Now, is there any other variable that we need to declare?
Result.
Result, very good. We have to declare results. So we're going to go back to our list, and at the very end here, we can do comma result, because it's going to be the same data type. It has to be the same data type as the numbers that we're going to use to calculate. Otherwise, we're going to get error. So that's something to be careful with. That when you're collecting a number, say for example, this was a real. Let's say for example, this was a real. So obviously, we're going to get a number with a decimal place. Now, if your variable that you're going to store that calculation into is an integer, then you might run into errors there, because integer only holds whole number. So when it sees a decimal place, it might run into some errors, it might not even work at all. So you have to be careful that when you're using data types, all of your variables match up, that are going to work in harmony with each other. So since these four variables are going to work in harmony with each other, they should be the same type. So if all of them are going to be integer, all should be integer, or else all should be a real data type. Are you guys following so far?
Yes, sir.
Yes, sir.
So why does it behave like that? So remember, we're looking at declaring variables. So that's what we're looking at right now. No, don't do that. Can you? No, don't do that today. So we're looking at declaring our variables, and this here is an example of declaring variables there. So now, going back to the building out our pseudocode. So notice we have our title, pseudocode test. This section here is declaring our variable. Remember, this is two examples here. This is example 1, and this is example 2. So now we can specify, before we go into that also, so that there is declaring, I'm going to put it to the side. So this is declaring variable. After you declare your variable, what you can also do is something called initializing variable. Does anyone know what the word initialize mean?
Like assign something.
Assign something, good. So to assign or to give it a value, give something a value. Assign a value or to give it a value. So this is technical knowledge. What can happen, say for example, with this program that we are running right now. So with this program that we're running, we are going to enter three numbers: number 1, number 2, number 3, and it's going to calculate it. Now, just say for example that after it finished calculating, say for example, number 3. Number 3 has a value of 5. 5 plus 5, and we have another 5 here. So that's going to be 15 here. Now, with this program that we have right now, it won't happen. But it's going to mostly happen when you have programs that have a loop. And that is something that you guys have to implement into your program. So when a program has a loop, what can happen sometime is that a variable can keep a value. So for example, this number 3 here, even though you might want it to change to update to the new value, because it stayed within the loop, it kept the old value that it had before the in the first loop. So in loop 1, it got a value of 5, but in loop 2, instead of updating to the new value, it kept the old number. It didn't change and go to a new value. It didn't do that. So it kept the old value. And what's going to happen is that it's going to give you an incorrect result when you calculate once again. So the basic idea, or what I'm trying to say so far, is that when you're inside of a loop, a variable can keep its old value. It all depends on how you create the loop. But a variable can keep its value, and when it keeps its value, the old value, it can give you a wrong calculation. Are you guys following so far?
Yes, sir.
So you do not want that wrong calculation. You want the correct calculation, what you're supposed to get. So in those cases, what you would do at the beginning of a loop, or at where it is necessary in the program, you initialize the variable. So that variable that is going to change, you might want to give it a starting value so that it doesn't keep the old value. For example, you could say that result is going to equal to 0. You could say number 1 is also equal to 0. So that there is initializing your variable. Now you don't need to initialize all your variable. That's what I'm trying to explain. You don't need to initialize all your variable. You only need to initialize the ones that is going to be reused inside of a loop. And to initialize it, to give it a starting value in the loop, so that when it starts over that loop, it starts over with a new value, with a fresh value, basically resetting that value back to 0. So it doesn't affect any calculation. So let me see something before I go on any further. Let me see if it's part of your mark scheme. Where's programming? Spreadsheets. Alright, so yes, it's a part of your mark scheme. So notice you have initializing the variable there. So that there is how you initialize a variable. by giving it a value. So you simply say the variable is equal to 0. It doesn't even have to equal to 0. You could say that the variable is equal to 7 or any value that you want. So for example, I'm going to give you guys another example. Say we have a variable of VAT. This is an example. We have a variable VAT. Now VAT, we're going to give it as an integer data type. Now, instead of you asking persons to input what is the value of VAT, does VAT change or does it have a constant value? Ali, you said something, I didn't hear it. Yes, does VAT have a constant value or does it change?
Sir, it can have a constant value.
It could have a constant value. It does have a constant value. So it's going to remain the same throughout the program unless the government says that VAT change. So in a situation like that, instead of asking persons every time the program is run to input VAT, you could initialize that variable. You can say that VAT is going to equal to 14%. Now, you cannot say 14% because the system would not recognize it. So it might be better to put it in its decimal format, which is going to be 0.14. So use that value there now throughout your program. So we just learned two things here. We learn how to initialize a variable to give it a value, and we also learned how to create a constant. I'm not sure if any of you just realized, but we just created a constant inside of our program, inside of our pseudocode. So by giving it a value, and it's going to remain with that value, we have just created a constant here also. Are you guys following?
Yes, sir.
Yes, sir.
So as I mentioned already though, it doesn't mean you have to initialize all your variables. You just need to initialize the one that would be used inside of that loop. But as we go through it, as we go through the programming, you're going to notice when your value is not calculating correctly because it's in a loop, that's when it should come to you that that variable there should initialize or basically reset back to 0 to get the right calculation. All right, now what do we need to look at next? Let's see. Good. So you guys should have the, so after this now, in your pseudocode, you could put in your inputs, you're going to put in your processing, and then you're going to make your outputs, and then you're going to end your pseudocode. Not sure why the software gave like this. Can't you get smaller? The more you make it smaller, the page gets bigger. How does that make sense? Alright, either way, there's all the information there reviewed on the page. So that there is going to be your basic layout for your pseudocode. So in your processing is where you're going to have your loop. So that's what we're going to look at today. So I've shown you guys how to create a basic pseudocode so far, by how to initialize your variable, how to declare your variable, how to initialize your variable, and how to put in your basic input, processing, and output. So today we're going to continue with if statements, conditional branchings, further adding to the processing parts, and then we're going to move on to loops later on. All right. Any questions before we move on though? Before we start conditional branching? All right, no questions. So let's move on. So next we're going to look at conditional branching. So in the processing part, we can add some conditions. For example, just like in spreadsheets, say for instance, I am grading you guys and we have a test that is running. So we have a condition of whether students have passed or whether students have failed. So what is the condition? The condition is if the student's grade, if it is greater than 50%. That's the condition there. So remember, condition means test. If the condition is true, we carry out one part of the we carry out the true part, and that's going to be a pass. But if it is false, then we carry out was in that false part of the if statement that was in spreadsheet. It's similar to your programming now. You're going to do the same if, and you have a test, and you're going to have a true section, and whatever is in that true section is going to be carried out. So for example, this could have been print pass, print the word pass, and this could have been print fail. So there's the false part there. No one told me I wrote false there. It's supposed to have been fail. Because I was wondering why I was saying false twice. So this here is supposed to be fail. So we have a test, we run that test, and from that test now, there's a true and a false. The person's grade, it can either be greater than 50%. If that part is true, that part of the program is going to be carried out. We print the word pass, that student has passed. If it is false, if it is in fact less than 50%, then that's going to be false, and we print or we carry out that part of the program. And that's basically what we'll be looking at right now, conditional branching. So conditional branching is used when there is a choice between two options. Two types of conditional branching are if then and if then else. So we're going to start with the if then. Let me change the color back to blue. So the if then statement suggests that one or more statements will only be considered based on a condition or the answer to a question. So here's a breakdown. We have if, which is the keyword, which is the statement, if, and then we have a condition or a test. Now, if it is true, then carry out the statement below here. So if it is true, then carry out the statement here. Otherwise, end. Now, sometimes the keyword and if is used to indicate the end of the if-then statement. So this here is just to indicate the end of that if statement. Any statement below the end if in the pseudocode is therefore part of the general pseudocode and not specific to the if-then statement. So think of the if statement like a subsection. So this here is your pseudocode. So it's not like the loop. Remember, your program still is reading top to bottom. So it's going to read what's at the top, was here, and then it's going to read a if. And then the if is going to have different parts inside of it. And remember, not everything is going to be carried out. Why? Because there's going to be a true part and a false part. So not everything is going to be carried out. So if the true part is carried out, that means false is going to be ignored. So maybe only this part here is going to be carried out, and this part here is going to be ignored. So it's false. So what it's going to do now, when it sees that it carried out the true part, it's going to look for where does the if statement end. And that's where it's going to see the end if, and then continue with the rest of the pseudocode. So remember, it's reading top to bottom. It's reading the codes at the top. It reaches that if statement. It carries out the tests. It carries out the tests. And if it is true, whether it's false or true, it carries out that part, and then it ends that if statement. And then it continues the rest of the pseudocode, or the rest of the program. You guys understand how the if statement works?
Yes, sir.
Yes, sir.
So let's use an example. You wish to output the total of 3 test results, but only if the total mark is greater than 50. So you want to output the total of 3 test results. So we have 3 scores from 3 persons, and we're going to output it only if it's greater than 50. In this case, we use the if-then statement. The pseudocode below shows that the 3 marks are each input into a variable. So 3 marks going to go into 3 different variables, and the marks are added, and the sum is stored in a variable called total. The if-then statement is then used to check if the total mark is greater than 50. If total mark is greater than 50. We do not know the value of the 3 marks that will be input. Therefore, if the total mark is greater than 50, then its value is output. The sequence of statement stops there. So we have the example here. Example 7, print the sum of 3 numbers if their total is greater than 50. So line 1, we have our title. Pseudocode underscore 7, add 3 numbers. Line 2, we have our input. Read number 1, number 2, and number 3. Line 3, we have our processing. This is the starting of our processing. We have a calculation, add number 1, number 2, number 3, and store it inside of total. Continuing with line 4, we continue in the processing, and we're going to run an if statement. We're going to test if total is greater than 50. If total is greater than 50, the total that we carried out above, then we have our output, then print total. Then we're going to print total. So we're going to add these three numbers together, check to see if it is greater than 50, that total is greater than 50, and print the word total. So if you guys have noticed so far, this if-then statement is only checking to see if it is true. Have you guys noticed that?
Yes, sir.
So that here is only checking to see if it is true. So when we go to if then else, this one here, that is when we're going to check for false also. But right now, all we're checking to see is if it is true. If it is true, carry out that instruction there. Now, let's break this down and try to get a better understanding. Let me circle off the if statement so that you guys can see that clearly. So what is in red is the if statement from starting to ending there. This is the if statement. So let me look at a simple example to see if you guys process it correctly. So number 1 is going to be 10. Number 2 is going to be 20. And number 3 is going to be 5. What is the output?
Nothing, sir.
Nothing. We have nothing.
Yes, sir, nothing.
2 nothing.
Sir, I think it's nothing too.
Nothing. Okay, we have 3. Anyone else?
Nothing.
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 Okay. Alright, so majority so far is saying nothing. So how do we end up with nothing? Well, let's run through the program. So number 1 is 10, number 2 is 20, and number 3 is 5. What are we supposed to do? Add those 3 numbers together and store it in a variable called total. So 20 and 10 is 30, and 5 is 35. So our test is going to be if 35 is greater than 50. Is 35 greater than 50? No,
Sir.
it's not greater than 50. So what is going to happen to the program? Let me erase this left hand side so you guys don't get confused. So what's going to happen? Remember this test here, this then, is only if it is true. That then is only if it is true. So since it is not true, what is actually going to happen is that it's going to true if then is not true, 35 is not true, and it's going to end the if. It's going to look at this code, says it can't do anything with that then, print total, can't do anything with it, end the program, end the if, and then end the program. So remember, it's going to go down this way, it's going to go down this way. So it's going to go to then print, can't do anything there, can't do end off with the if, and then end with the program. So as you guys said, nothing will happen because 35 is lower. Alright, let's use another example. So we have 20, 10, and 30. Twenty, 10, and 30. 20, 10, and 30. What is your output?
It's 60.
Yeah.
So we have 260. Anyone else? Give you guys some time to think. Anyone else?
Sir.
May even say 60. All right.
60, sir.
Daniel says 60 also. Good. So you guys had enough time to think. So let's run through it now. So we have to add the three numbers together. 20, 10, that's 30 there. And another 30 is 60. So we have to check to see if 60 is greater than 50. Yes, that is true. So in the if-then statement, if the test is true, you have to carry out what is the next step. So the next step is to then print total. So we're printing that variable total. So we're not printing the word total because total is not a word or a phrase, it's a variable. So we're printing the variable total. So that means whatever is inside of the variable is what is going to appear on the screen. The value 60 is going to appear. So, are all of you clear on that? How the if statement works, the if-then statement?
Yes, sir.
Yes, sir.
Yes, sir.
Great. So that is how the if-then statement works. Remember, it only checks to see if the value is true. Where's undo? There's no undo. Either way. So if you wanted to, say for instance, you wanted to print the word total, but total is a variable. Does anyone have an idea what you need to do?
Put it in quotation marks.
Very good. You put it in double quotation marks. Quotation marks. So that is how you indicate a word that you want to output, or a phrase. You put it in quotation marks. So if there was more words, if there was an entire phrase, total is, and then you could put that in quotation mark, and even inside of it you could put like a colon, and then you can put the variable name. So this is how we have words before the actual variable. We can say total is in quotation mark and then put the variable at the end of it. So it's going to print total is and the variable, which is going to be total is 60. So when you want to print a variable, you just use the variable name by itself. When you want to print a word or a phrase, you put it in quotation marks. All right, so let's continue. So the condition or question asks is the total mark greater than 50? So if it is, then the condition is true and the mark is indeed greater than 50. The next statement is the sequence indicates to output the total mark. So as we just saw, the next sequence is the output. That is, if we use 20, 25, and 10 as the three marks to be input, then we're going to get a total of 55. And since 55 is greater than 50, it is expected that the value 55 will be output. The if-then statement does not consider if the total mark is less than or equal to 50, as there are no statements in the pseudocode that instructs the result to be output. So it does not look at the false part. If it is false, it does not look at it. It's only looking at if it's true. If the total mark is less than or equal to 50, the condition is false, then the next statement, then print total in the sequence, is going to be skipped, as I said already. And the pseudocode is going to reach the end without printing anything. So that's how we end up with nothing as the first example. So the keywords in this example are read, if, then, print, and if, and end. And the variables are number 1, 2, 3, and total. So this is the general structure or format for the if statement. So if you remember this format here, it's going to help you to remember how the if statement works. So you start off with if, and you have a condition, and if that condition is true, you carry out the then statement, only if it is true. If it is false, you go straight to the end if. So if condition is true, as mentioned, execute the true statement. If is a keyword, so if is a keyword. The condition, what is a condition? Condition is a Boolean expression, which means that the value is going to be either true or false. So it only has one of two states. And what is a true statement? What is a T statement? They are one or more statements that are included only if the result of the condition is true. What is an if? It tells the computer that the if then statement finishes here. If the condition is false, the true statement is skipped. That is, you do not execute them. So that is the general structure or the general format of the if statement. So let's look at another example. So consider the following example to find out if a student is younger than 13 years old. If so, then we want to output the statement, student is not a teenager. For this, we need to use an if-then statement. So we're going to create an IPO chart, input the age, and then we're going to check to see if the age is less than 13. If age is less than 13. If it is true, then output student is not a teenager. So if they are less than 13, we're going to get this output here. You can write this pseudocode much as it is written in the above statement. So once again, we have our title, we have our input with our keyword input age. So we're going to input a value. We have our process in here. If age is less than 13, and then we have our output. Then output student is not a teenager. So let me give you guys some example. Say the age is 8. What is going to be the result?
Student is not a teenager.
Okay, that's one. Anyone else?
Yes, sir. Student is not a teenager.
Good. And the rest of you? Agree, disagree?
Agreed, sir.
Agree.
Okay, good. So that there is true. You're gonna get the output student is not a teenager because it is less than 13. Um, Now, what if the age is 14? What is the result?
Nothing.
You have one nothing.
Agreed.
Two nothing.
Sir, nothing.
Three nothing. So nothing will in fact happen because 14 is not is not less than 13. So that's going to be false. So it's going to skip everything. It's going to skip all the true statements because remember it doesn't look at the false, skips everything and goes to the end of the if. Now there's nothing at the end of the if, so the program ends there completely. So we have another variation of that pseudocode here. Let's just end off this example. So we have another variation here of this pseudocode. It is to input the student's year of birth and the current year to calculate the student. So we have a title here. So this year, so if you notice, we're initializing a variable here. Notice that? So we're initializing the variable. We're giving it a value. And then we have input. We're inputting birth year. So somebody's going to put in the birth year. So somebody is born in 2008. Then we have a processing. Calculate the age. So what is going to be the age if the year is 2019 and the birth year is 2008? 11. And then we're further going to process if age, because remember 11 is going to be stored inside of age. If 11 or age is less than 13, which it is true right now, then we're going to get the output of student is not a teenager. So note that this year is an example of a constant where the value 2019 is not modified in the algorithm. The variable birth year, however, changes when new data is input. All right, so what have we considered for today? Remember I showed you guys the basic layout of your pseudocode. So you guys can start on that also. You have your title. Let me delete this part at the top here. So you have your title. This here is your title. And then you declare your variables. These are examples here of declaring your variables. And these are examples of initializing your variables. And then after you finish doing that, you can indicate what is your input, carry out all of your processing, all the calculations, and then give your final output and end your pseudocode. Then I showed you guys how the if statement works. It runs a test. It's only going to have true and false. And you put your codes on the true or false. If it's true, what is inside of the true is going to be carried out if it is true. And what is inside of false is going to be carried out if it is false. So the only if statement we looked at today is the only conditional branching we looked at today was the if then. And basically the only thing to remember here is that the main point to remember is that it only checks to see if it is true. That's the main point to remember here. Your if then statement only checks to see if the test is true. If it is true, it's going to carry out the statements, but if it is false, it is going to end the statement, that if statement. Alright, if you guys don't have any questions on anything we looked at today, that is the end of today's class. Enjoy the rest of your day.
You too, sir.
You too, sir.